So now we start to demonstrate our case study experimental. In this experimental, in summary, firstly, we create a Flask container and a Mexico container. The Flask container will access the Mexico container for queries through a custom Docker network and display the query result from the Mexico on the Flask container's web page. Also, during this process, we need to create a Docker worm to save the database date. So in this way, we could demonstrate how two containers communicate with each other through Docker network. And also, next step, we need to build a Docker image and push it on the Docker hub and deploy it on the Azure cloud platform. So first step, we needed to create a custom Docker network so that two containers could communicate with each other. We use the command Docker network create. And so the next step, we needed to create a Docker worm to save the database state, ensure that even the Docker is stopped, the data wouldn't lost. We use the command Docker worm create. Step, we need to run the Mexico container using the Docker and connecting it to the network we created earlier and mounting the worm created earlier. In this way, our data from the Mexico database will be saved in the DB data worm, and we execute those commands here, and we successfully created the Mexico server 2 Docker here. Then we will create our Flask container Docker field. This Docker field will create a Flask container based on the Python 3.8 image. Basically, we will install the necessary libraries and we use the exposure instruction to declare that the container will listen on the port 5000, allowing external access to the Flask application. Finally, we use the CMD instruction define the default command to be executed when the container start, which is running to run the Python app.py to launch the Flask application. So this is our doc file. This is our app py file. Basically, it's a very simple Flask application based on the Flask framework, and we define a route here. So when we assign the route path, it connects to a MySQL database. So MySQL database execute a query and return the result from the query. And also, if the application is run as a main program, it starts the Flask application use the app run host, allowing it to be accessible at any address within the container. The next step, we needed to build and run our own Flask Docker container. So basically, we just connect it to the network we created earlier, and we map the container port to the 5000. So in this way, external user could access our web page. We execute this command, and right now we could visit our web page. Visit the web page here. You can see we have the register from the MySQL container. And the next step, we need to push it to our Docker hub and deploy it on our Azure cloud platform. So firstly, we finish the push step. We need to log our Docker hub, and before we push it to the hub, we need to tag our image. Use the command doc tag, and we give a tag of our image and doc push this tag to our the hub, and yeah, we finish the push And in our .hop web page, we could see here we just pushed 1 minute ago the Flask app here. Then we needed to deploy the doc image to our Azure cloud platform. We will use the Kubernetes service to deploy the image and finally through the web page to visit it. So first step, we need to create our own resource group here. And then we need to create a Kubernetes service with this command and with the name myaks and with one single node and enable the monitoring, and we execute this command. The Kubernetes service will automatically deployment and manage our Docker container application. And then we needed to create one command line to connect to our Kubernetes service that we create before. By this way, we could use this tool to manage and control our application. And we execute this command here, and yeah. Then we needed to create a configuration field to deploy and manage our Flask application within the Kubernetes service. This field contains two main sections. The first one, deployment. The deployment section is a response for defining how to create and update instance of the Flask application. Specifically, we define our container here, the name, the image from the hop, and the port. And the next section is the service. The service section is configure how to allow external access or other internal service to access this service. So we define the load balance and the port. Then we use the Kubernetes command line tool to deploy the Flask application with the configuration field we just create. And then we could use these two commanders to check the running states of our application. You can see here the Flask app is running right now. So then we could use this command to get the external visiting URL link of our application. So we could see here the external IP address and port. We could use this address and port to visit our web page here. That's all.